Okay, so I have been asked to look at a function f defined by the rule divide the input by 2 and add 3. So we're going to write an expression in x to represent this function. Okay, so x is my input. So f is my function. So f is a function with an input x. Okay, so f of x. And the function is that the input is divided by 2 and then I add 3. So that is my function there in terms of x. So I am asked to find a few values for f of 4. Okay, so when I input 4, instead of having an input x, I now have an input 4. So exactly where x was earlier, I now have an input of 4. So I have 4 over 2 plus 3. So that means it's 2 plus 3, which is 5. Okay, so I have, for an input of 4, I have an output of 5. So if I want to write this as a pair, so I can either write it as f of 4 is equal to 5, or I can say 4 comma 5. Okay, so I can write it as a pair there of coordinates. Okay, so next one we are going to do is f of 18. Okay, and we are also going to do f of 6. F of minus 6. So you can try these yourself now. Okay, so I'm going to have 18 over 2 plus 3. So that is 9 plus 3, which is 12. Okay, and minus 6 then. So minus 6 over 2 plus 3. So that is minus 3 plus 3, which is 0. Okay, so if we were asked something like, so let's have a look at part 3. F of x equals, and we're given a value. So far what we have is f of, and they give us a value there. So they, in the ones so far, have replaced where x was with a value. So like this, f and then 0 in brackets means that I am replacing x with 0. Whereas in this next part, they aren't actually going to replace x, but they're going to replace what f of x is equal to. So remember, up until now, we had f of x, where just what is inside this bracket is what x is equal to. So x there is equal to x. Whereas this whole part together, f of x, we know is equal to y. Okay, so over here, if I was to draw this as a point, x is 4, y is 5. X is 18, y is 12. X is minus 6, y is 0. Okay, so in this next one, I am going to be asked, what do I have when f of x is equal to 9? Okay, so what they're telling me there is, I don't know the x coordinate, but I know that the y coordinate is 9. Whereas over here, I knew the x coordinate and I was finding the y coordinate. So I was finding what f was equal to. Whereas now I'm going to be trying to find what is x equal to. So, I know what f of x is. Okay, f of x is x over 2 plus 3. So I'm going to replace f of x with what I know f of x is equal to. Over here, I was replacing x with what I knew x was equal to. Okay, so they just replaced the x part within the brackets. They didn't replace anything to do with the f of x. Whereas here, I want all of f of x replaced. So I'm going to get rid of all of this f of x and I'm going to replace it with the full function. So I am going to have x over 2 plus 3 is equal to 9. Okay, and now I'm going to be able to rearrange this to find what x is. Okay, so this is our second point here. Okay, so to find f of x equal to something means that we're finding the x value when y is, so in this example, 3. Okay, so we're letting the full function equal to 3, or in this case, we're letting the full function equal to 9. Whereas over here, we were only letting the x coordinate equal to the number they gave. Over here, I'm letting the full function equal to the number that they gave. So, now that I have this, all I need to do is figure out what x is. So we know how to do that. That is back in our first chapter of algebra. So I'm going to take 3 from both sides so that I get x over 2 is 6. And I want to get rid of the 2 that's dividing. So I have to multiply both sides by 2. So that the 2 that's multiplying and the 2 that's dividing cancel. And I am left with x is equal to 12. Okay, and we know how we can verify this if we wanted to. We could see if I was to put x equals 12 back into my function, do I get 9 out? Okay, so if ever I was asked, let's say, to verify, so if I wanted to verify that x equals 12 when the function is equal to 9, okay, then I would literally just be putting back in, so f of 12. Okay, because f of 12 is equal to 9 is what we've just figured out. But let's confirm it, okay, because it's sometimes easier to work a different way towards getting your answer confirmed, because you might not spot a silly mistake, or if you made a silly mistake the first time, you might make it again the second time. So looking for a different way to do it is always kind of the best thing to do when you're verifying your work. Okay, so we're inputting x as 12 over 2 plus 3. So I get 6 plus 3, which is 9, which is what they told me it was equal to. So that's perfect. So that means, yeah, that's correct. X is equal to 12. Okay, we weren't asked to do that, but if we were, that's one way of verifying it. Okay, now we want to know next, what is f of x equal to? Okay, so f of x. So what does that mean? So where I have my function, okay, and my input was x. Now my input is f of x. So I had a function, f, okay, and now it is f of x. So where I had x before, I am now going to put in my function. Okay, so I have something divided by 2 plus 3. Okay, and what is being divided by 2 plus 3 is the function. So the function is x over 2 plus 3. Okay, so I am going to run out of space here, so I'm just going to go up here. Okay, so I'm going to get that is equal to, so x over 2 divided by 2 means that it is x over 4. Okay, plus 3 divided by 2 is plus 1.5. And then I have the plus 3 from the end. So it is going to be x over 4 plus 4.5. Okay, so that is applying the function onto x twice. Okay, so x over 4 plus 4.5. Okay, we can write it a few different ways, but that's perfect. Next is what is f of x minus 5 equal to? Okay, so f of And again, now my input is x minus 5. Okay, so my exact same function. So something being divided by 2 plus 3. And now the input is x minus 5. Okay, so same again. I'm going to have x over 2. The minus 5 needs to be divided by 2, so it's minus 2.5. And then I have plus 3. So that is going to give me x over 2 plus 1 over 2, or a half. Okay, so I can write that a bit nicer if I just say x plus 1 over 2. And actually, if I look back up here, it doesn't really look nice if I'm mixing fractions with decimals. So I actually might write this as something like x over 4 plus, and we can do them again with the same denominator so that I can write it all over 4. So if I want to write this as something over 4, I need to multiply it by 4. So I'll have plus 18 over 4, so that I can write it as x plus 18 over 4. Okay, just so that I'm not mixing fractions and decimals. It's kind of fine over here because it's like one fraction and one whole number, but we don't want to kind of be looking at like a half and then 2.5. It kind of just looks nicer if we keep it either all with fractions or all with decimals. Now, we want to know what is f of x plus k as an input. We want to know what that is equal to. So I am just going to rub out some stuff over here. Actually, I'll just rub it all out except for our function. Okay, so you can try this one yourself first. Okay, so what would we get if the input was x plus k? Okay, so x plus k. So what is my function then? Okay. So again, my input is going to be divided by 2, and I'm going to add 3 after I divide it by 2. So I'm going to just have my input there as x plus k. Okay, that's kind of enough. If you want to start writing it all as fractions and stuff, you can, but because that's a whole number, we don't really have to do what we had done in part 4 and 5. And part 7 says, show that 1 over k times f of x plus k minus f of x is equal to a half. So, part 7. Let's have a look at what we are showing here. Okay, so we want to show that 1 over k times, so remember we just use square brackets to differentiate sometimes between a curved bracket and another curved bracket. So if within one curved bracket there's another curved bracket, it might be a little complicated for us to see. So sometimes we just switch them out with square brackets, and it doesn't really mean anything more than that. Okay, so that's just all that is just a normal bracket to show that it's multiplying. And within that bracket, we have f of x plus k minus f of x. And they want us to prove that that is equal to a half. Okay, so I'm going to switch out what I know here. Okay, so 1 over k, we're just going to have to leave as is. And then I'm going to have, so f of x plus k is right here, like all this. Okay, so I'm going to switch that out for what it's equal to. So x plus k over 2 plus 3. Okay, and pause this and try it yourself if you think you could do it. Okay, I'm literally just switching this stuff out, and then after that it's algebra. Okay, so just switch it out with the functions that we know they're equal to. So that's x over 2 plus 3 is what's being subtracted. Okay, and they want us to show that that is equal to a half. So straight off, I'm going to have a plus 3 and a minus 3. I'm just going to cancel them. Okay, that's going to be a minus 3 because there's a minus outside the brackets. That's going to change it to a minus 3. So I'm just doing that now to save myself a little bit of work. And then all I have to do is figure out what is x plus k over 2, and then minus x over 2, which is just going to be minus x all over 2. Okay, so I had x plus k over 2 minus x over 2, so I've written that all together as one big fraction because they already had a common denominator. Okay, and I want to show that that is equal to a half. So I'm going to start back up here. And I'm going to say that that is 1 over k times, and x minus x is going to go to 0. So that is times k over 2. Okay, and that is equal to a half. So I know if I am dividing by k out here and I am multiplying by k in the brackets, that means that they're going to end up cancelling. Now, if you want me to show that a bit clearer, okay, that they're two fractions being multiplied together. So it's going to be 1 times k is k over k times 2, which is 2k, equal to a half. And then when I have k, multiplying the whole top and the whole bottom of the fraction on that side, they cancel. So I get a half is equal to a half.